Leslie?
Yeah. Oh,
You can go ahead and get started.
okay,
No problem.
gotcha.
Good.
Hi, everyone. My name is Leslie Fafita. I'm with Providence Engineering, and thank you for joining us for our webinar today. This one is going to be about how to put together an hourly emission rate file with AERMOD. If you have any trouble with seeing or hearing the presentation, just let us know. Okay, so in this presentation, we're going to talk about why you would want to use an hourly emission rate file in the first place, just some examples of situations where it might come up. We're going to talk about the structure of an hourly emission rate file, what it looks like. We'll talk about how to put one together to actually generate the hourly emission rate file. And then we're going to go through a couple of examples where we use AERMOD through BEAST to do a run with an hourly emission rate file. So the question about using hourly emission rate files, the first thing you want to find out is whether your source has a continuous or variable emissions. By default, AERMOD assumes all of your emission rates are continuous for all modeled hours. And if you're modeling for a permitting purpose, it makes sense that you'd want to assume that you're modeling your worst case emissions, for every hour in the meteorology to come up with kind of a worst case impact. But not all sources of emissions operate on a continuous basis. Some of them have irregular emissions, some of them are variable. Some examples of sources with irregular or variable emissions are anything that has a batch operation rather than something that's continuous. If you're doing engine testing or maintenance events, any kind of emergency event like emergency flaring. If you have piles of material and there's windblown dust that's associated from those piles, that's something that's not continuous. Any kind of emission event or a forensic emission event, something you're trying to recreate that happened in the past, emissions from spills, and also sort of patterns of truck traffic through your site are things that aren't always continuous in nature. So AERMOD has two kind of avenues for us to follow if we have a source with emissions that are not continuous. One of them is using an emission factor set, which is certainly the easier of the two options. And if that isn't going to work for your particular situation, you'll need to look into using an hourly emission rate file. I just want to talk about the differences between these two options. An emission factor set is used to represent periodic activities. It has to be dependent on some combination of hour, day, month, season, or wind speed category. So if you have an operation that is only emits during the day, you can turn on just the daylight hours and turn off the nighttime hours. Or it operates at a higher load in the summer than it does in the winter, you can adjust the emissions with an emission factor set. You can apply this emission factor set to any applicable set of met data, so it's pretty flexible in that sense. But you have to have some kind of activity that is periodic that can be predicted based on hour, day, month, season, or wind speed category. If whatever event you're modeling has nothing to do with what hour of the day it is or what the season is or what the wind speed category is, then you'll need to be looking at an hourly emission rate file. An hourly emission rate file is used to evaluate a specific event or a specific time period. It doesn't necessarily need to be a short time period. It could be anything from 1 hour to 10 years of data, but it is for a specific hour or 10 years of data. It's not for any given hour. The emissions don't need to follow any specific pattern, and the hourly emission rate file dates must match the dates that are in your MET data set. So if you have a MET data set from the agency from 2011 and you have an event that happened in 2017, those are not going to be usable with an hourly emission rate file. You'll have to process newer MET data to match up with your emission rate files. Okay. The structure of an hourly emission rate file is really just a bunch of line items with this prefix that says SO hour emiss. The SO just indicates that it's part of the source block within the AERMOD input file, and the hour emiss says this is one line item in our hourly emission rate file. And then right next to the hour emiss indicator, you have to put in what specific date you're going to be representing. So it's the year, the month, the day, the hour. And then after that piece of information is in, you have to tell it the source ID, you have to tell it the emission rate. And then beyond that, I have on this screen it just says AABBCC. There's 3 different parameters that you might need to use. It depends on what kind of source you're modeling. And we'll go through each of the sources individually to show you what those variables need to be. But one note is your hourly emission rate file is not developed in BEAST, at least not the way that we're going to do it here. So since it's going to go into AERMOD directly, when you put in your emission rate and any parameters that go into this file, they need to be in metric units. So our emission rate has to be in grams per second for point sources, volume sources, or buoyant lines. And then if you're doing an area, if you're modeling an area source, any kind of area source or a line source, the emission rates need to be in grams per second per meter squared. Otherwise, it will not be representing the right rate. Okay, so that's the general structure of each line in the hourly emission rate file. For a point source, we're just going to talk about these last 3 items on the list, what I'm calling AA, BB, and CC. AA is the exit temperature in degrees Kelvin. BB is the exit gas velocity in meters per second. And CC is not used. I think that CC is only used for volume sources. So the only other parameter that would go in your regular inputs for a point source would be the diameter. And I guess they're assuming that your diameter, your stack diameter, is not going to change from hour to hour. So there's no capacity to do that. And I believe that if your exit temperature and velocity do not change from hour to hour, you can just leave those blank, and they will. Pretty sure they'll populate from what's in the AERMOD input file. So again, that same note, only metric units are allowed in hourly emission rate files. Okay, if you're modeling an area source, an area poly, an area circle, or a line source, the AA is the release height. If you have a source that varies in height over time, you can change that there, and also the initial vertical dimension. You can, again, leave those blank if you have a source that does not vary in height or vertical dimension over time. Okay, and for a volume source, all 3 of those parameters are used. The first one is for the release height, then the initial sigma Y naught, and the initial sigma Z naught. If you have an area source, or a volume source, I'm sorry, that changes in dimensions during the period that you're modeling, you can do that here. And for a buoyant line, there's only one parameter you get to change, and that's the buoyancy parameter F prime. Okay, a couple of notes about the hourly emission rate structure before we go about putting one together. One is each line inside an hourly emission rate file must be in order. First, it has to be in order by source, and then by date. If you mix up the order of the sources or the dates, AERMOD will crash. The emission rates and the release parameters that go in your hourly emission rate file may be provided as integers, as numbers with decimals, or in scientific notation. But do not include commas in your number formats. That will cause AERMOD to crash. And do not include any really, really small values. I put together an hourly emission rate file that included some data that was collected from a SEMS, and the SEMS had some artifacts of, some of the calculations that it does to determine emission rates, and there was some kind of junk data in it, just some really, really tiny emission rates that probably didn't really mean anything. And when those rates found their way into AERMOD, it didn't like a really, really tiny number. So if you have a really small emission rate, something less than, say, 1 times 10 to the negative 20th, just call it 0, so AERMOD won't crash. So 0 is okay. It's just a really small number that causes the crash. The final hourly emission rate, the one that you actually want to feed into the model, is basically just a text file. You may put it together in Excel or some other spreadsheet program, but before you get it ready to actually put into AERMOD, it has to be saved as a text file. And you can do that directly from Excel by saving your sheet as a .prn. That's one of the options, the save options from AERMOD, and that'll convert that into a space-delimited text file, which is kind of what we're looking for here. Okay, and I know I mentioned before that each date in the hourly emission rate file must correspond to a date within the MET file. Now you can take your MET data and cut it to the exact size of your hourly emission rate file, but if you have a MET data set that's larger than the set of hourly emission rates that you're modeling, you can select a specific range of days from within your MET data by using that MET Options tab. Under the MET Options, there's one option that says Select Days. And so in this little example, I've selected March 5th, 6th, and 7th, just those 3 days to model by themselves, assuming those are the 3 days you have your hourly emission rate for. And another way to do this is under the MET Options tab within that subfolder. You do a MET start /end. I think in the example it says, again, starting on March 5th, hour 1, 2012. Oh, it looks like we're ending on the 7th on hour 27. That doesn't really make any sense, but let's assume it says hour 24, since there really isn't an hour 27. Anyway, you can cut and paste cut the selection of metadata that you're interested in using one of these options as well. Okay, so I'm going to go through an example of putting together one of these hourly emission rate files. And this one is a relatively simple example. It just has one source here. So in our example, we have NOx that's emitted from a new turbine. We're going to have a cold start. And as the turbine is starting up, our SCR is brought up to temperature over a period of 10 hours. So during that time, our NOx emission rate goes down as our SCR, starts to be more efficient, and our exit temperature starts to increase. So we have this 10-hour period where our exit temperature and our emission rates are different for every hour, although our velocity seems to be about the same throughout the period. Our source ID is called new turb. Our stack height is 50 meters. Our stack diameter is 1.5 meters. So what I've done is I've taken that table, this table right here, and made sure that it's in Excel. Okay, and so we're looking at just the first line here from that table. It has the hour, the specific hour, the exit temperature, the velocity, and the emission rate. And so what I want to do is take this information and put it into this format that goes into our hourly file. And so what I've done is I've broken this line into 2 pieces. The first half is the purple section, and the second half is the orange section. And what I'm going to do is I'm going to look at each of these sections and just use the concatenate function within Excel to merge the pieces that I'm interested in together. So first of all, just looking at this purple section. The purple section, I want it to say SO hour miss. That's our first bit of data we want in there. So oops, let me go back. So I put an equal sign and then quotes to say SO hour miss, and then ampersand. That's going to concatenate our data together. And the first thing I want to do is take the year out of the cell D11. D11 is our date, and it has all the information in it. It has the year, the month, the day, the hour, And if you tell Excel, find the year in this cell, it'll pull out 2016. That's the year. And then we want to concatenate this with just a space in between. And then we're going to take the month out of that same cell, another space, the day out of that same cell, another space, and the hour. And so when you, after you type this formula in and hit enter, this is the value it's going to populate. It'll have SO hour miss from right here. It'll have the year, which is 2016. It'll have the month, which is month 4, which is April. It'll have the day, day 21, and it'll have the hour, which is hour 10. So that's the formula that we're going to pull down for that first half of the line item. The second half of the line item is very similar situation. We're going to concatenate these things together. The first item here is the source ID. I'm calling the source new turb in my AERMOD file, so I'm just going to call it new turb right here. I'm going to concatenate this with G11, which is the NOx emission rate in grams per second, and then a space, and then I'm going to concatenate that with E11, which is the exit temperature in Kelvin, and then another space, and then the last thing in here is the exit velocity, which is 22. So once you type that in and hit enter, you'll get the value, which is the source ID, new turb, and then the emission rate, 120 grams per second, the temperature, which is 200 Kelvin, and the exit velocity, 22 meters per second. So then I'm going to take basically this purple thing right here and the orange thing and concatenate these two together, just put an ampersand between these two, and I'll end up with the whole line. So this is the first line that needs to go in our hourly emission rate file. It's all the right data in the right format. So let's say I've made an Excel formula in this cell right here. It looks like H11 that does this concatenating deal right here. So I'm going to take this and I'm just going to pull it down so it populates through however long my set of emission rate data is here. So this highlighted portion that I have in yellow, this is all the data that needs to go in my hourly emission rate file. So all I need to do here is copy this data and put it inside a blank text file. That's the easiest one. So I'm going to separately open a blank text file. I'm going to call it ex1_nox_hourly.txt, and I'm just going to paste these values inside of it. Let's assume I've done that and put it on my network. So we have our hourly emission rate file. It's already sorted. It's in the right order. It's saved on our network. It is a text file. So in order to include it in our AERMOD run, what we do is in BEAST, under the source options, there's a tab that says File. And in that tab, there's a checkbox that should be automatically checked that says No Hourly Emission Rate File. The first thing you want to do is uncheck that box if you're going to select an hourly emission rate file. Once you've done that, you want to go down to this File tab and find on your network wherever you've actually put the hourly emission rate file. I've linked the file that I have, right here. It says ex1_nox_hourly.txt. So I found the file, but before you can actually run it, you have to do one more thing, and that is to select the sources that are actually in your hourly emission rate file. When you click this Select Sources, you're going to get a pop-up that looks like this, and it should show all of the sources that you have in your BEAST file. Now, in my BEAST file, I only have one source, the new turbine, but it's possible that you're going to have a whole bunch of sources, and you won't necessarily have hourly emission rates for all of them. So this will give you the opportunity to tell AERMOD which sources you are actually including in the hourly emission rate file. So this one I'm going to go select it. You can double click it, or you can click select and hit OK. And then before you run the model, just make sure again that your met data matches the hours in the hourly emission rate file. And you can go ahead and run AERMOD as usual, and it should be just fine. I'm going to go back one slide just to clarify something real quick. If you noticed on this tab with the hourly emission rate file, at the bottom we have an option to generate the base file directly from BEAST. because Beast can create a base file that will contain your selected sources for the selected year. First, you must select a file and the names of the sources above, but then you can select a year and generate a base file. So if you click Generate Base File, what it's going to do is it's going to produce something that kind of looks like this. This is one I did. This is not for the new turb, it's for something else. But this has the right structure of the hourly emission rate file. It's got the SO hour emiss, it's got the year, and that's the year that you select right here. The month, the day, the hour, your source ID, mine just said stack. And then notice there's a blank space right here. That's where your emission rate goes. Beast doesn't know what your hourly emissions are, so it's left that whole column blank. And then it's gone ahead and put in the parameters that you have listed. Oh no, that's not true. It must have put in your emission rate from the from whatever's in the Beast file. So this is the rate that you have in there by default, the continuous rate, and then it has the temperature and the wind and the exit velocity. So if you decide to use this generate base file option, you can open this file that Beast produces for you, but you're going to have to go back inside the text file and change all of your emission rates to whatever the hourly rates are. So somehow this is going to end up back in Excel anyway. But if you really didn't like the concatenating thing that we did earlier, you can have Beast create this base file for you, but you will have to copy and paste this stuff and put it all back in Excel later, so you can replace these hourly rates with the correct individual hourly rates that you want to use in the model. So that is available just as another option. Okay, so that was example one. It was relatively simple because we had just one source. We're going to do a little bit more complicated example here, and that's building an hourly emission rate file with a number of sources. So we're going to talk about the same 10-hour cold start period for our new turbine, same emission rates from that source. But during the same 10-hour event, we have two existing turbines that are going to decrease in load a little bit as the new turbine ramps up. So we have this original set of information here for the new turbine, and then we have a change in emission rates for turbine 1 and turbine 2 during that same period. I'm thinking now I probably should have decreased the exit velocity a little bit if we're ramping down on these. But no matter, this is just an example. So anyway, we have three sources that are all operating, and they're all going to have hourly emission rates during this 10-hour period. So the first thing we need to do is make up our concatenating functions just like we did before. We have the SO hour emiss, we have the year, month, day, hour, the source ID, the emission rate, the temperature, and the exit velocity. And we've done that for the new turbine, turbine number 1, and turbine number 2. Now, before I can copy this information into my new hourly emission rate text file, we have to sort this data so it's in the right order. First by source ID and then by date. So this is the order that it has to be in. When you put these sources into your Beast file, they're in a specific order. Right now it says turb 1 is or source 1, then turb 2, then new turb. It has to be in this order in the hourly emission rate file, or AERMOD will give you an error. So we want it to do this specifically, where we model, say, hour 10 turb 1, hour 10 turb 2, hour 10 new turb, and then the same three sources for hour 11, same three sources for hour 12, et cetera, until we get to the end of our period. So if you just had 10 sources, you can probably just copy and paste these within Excel and put them all in the right order. But if you have if you have a pretty long period that you're modeling, not just a 10-hour block here, something that I've done to make it a little bit easier is to give each one of these sources its own sort order column. So because turb 1 is the first one that I want in my sort, I give it a sort order number, just 1 through whatever, however many entries there are. And then for turb 2, since it's the second one, I'm just going to take this initial sort order and add like a very small number to it, like 0.1. And then for the last one that goes in the sort order, which is the new turb, I'll add a 0.2 to it. So we have a separate sort order for each one of these. Then I can take all 3 blocks for the 3 different sources and put them in one big column and then sort by the sort order. Once I do that, these are all in order just numerically by the sort order, I now have everything where it's supposed to be. I have turb 1, turb 2, turb 3, all for hour 10, turb 1, turb 2, I'm sorry, not turb 3, the new turbine for hour 11, etc. So this is now ready to go inside the model. So just like we did last time, we'll go under source options and the file tab, and if it's not already unchecked, you want to uncheck this no hourly emission rate option, and then go to the file and select wherever you saved your hourly emission rate file. This one I called exercise 2 _ NOC _ hourly, and then select your sources. You'll get a pop-up that looks kind of like this. In this case, I have hourly emissions for all 3 sources, so I've selected all of them here and hit OK. And then once that's done, you can go ahead and run AERMOD. Let me see. Okay, just like the previous example, again, make sure your metadata matches the hours in the hourly emission rate file. I'm assuming it does. You can run AERMOD as usual. Okay. For those of you that use Beast Express, you may be wondering, hey, can I do this with Beast Express? And the answer is, in the vast majority of cases, yes. Beast Express can handle hourly emission rate files. I did have a problem with it once doing some SO2 regional attainment modeling. This is something where we had SEMS data for dozens of sources in a very, very large hourly emission rate file. And what happens in Beast Express is if you say, I want to split my file into 50 partitions, it makes 50 copies of your hourly emission rate file. And that can get, that can be overwhelming depending on the size of your hourly emission rate file. So if you're talking about, you know, megabytes, gigabytes, or hundreds of megabytes or gigabytes of size of an hourly emission rate file, that's where you'll end up with a problem with Beast Express. So if you happen to be in that situation, call us. But for any other case with hourly files, it should work just fine with Beast Express. All right, that is all I had. I hope that you enjoyed the webinar, and I'd be happy to take any questions you might have about hourly emission rate files. Hey, Demetria, I can't see the chat piece, so if there were any questions that were chatted in, I can't see them.